Given that a large number of the audience's investors are really interested in the data center business, it would be intriguing to hear your and the company's thoughts on the medium and long-term opportunity set. The next industrial revolution is being facilitated by your industry, as you are well aware. What difficulties does the industry face? As we sit here today, briefly share your thoughts on the data center market. Since air is a terrible conductor of power, these enormous data centers are incredibly inefficient. We want to densify a few, enormous data centers that are 50, 100, or 200 megawatts into a really small data center. Even though Nvidia server racks can cost up to a couple of $1 million each, they are a cost-effective solution for replacing thousands of nodes. The astounding thing is that replacing all of those and consolidating them into a single rack is less expensive than simply replacing the cables that connect outdated general-purpose computer systems. Moreover, densification has the advantage of allowing for liquid cooling, which is advantageous for very small data centers but difficult for very big ones given their density. Therefore, the first thing we're doing is updating data centers, which includes making them faster, denser, and more energy efficient. It's considerably more efficient and you save money and electricity. That would cover the next 10 years if we only concentrated on that. Let's simply speed that up. There's a second dynamic now, of course. Because of the massive cost reductions brought about by Nvidia's accelerated computing, we've scaled computers by 1,000,000 times in the previous 10 years, as opposed to Moore's law, which is 100x. So, if your plane could move 1,000,000 times quicker, what would you do differently? In what way would you respond if people suddenly said, "Hey, listen, instead of trying to find out what the features are, instead of trying to figure out what the algorithms are, why don't we just use computers to develop software? We will simply provide the computer with all of the data, including the predicted data, and allow it to determine the algorithm, generative AI, machine learning, etc. As a result, we have done it so extensively across so many data categories that computers can now comprehend not only how to handle data, but also its meaning. Additionally, it is capable of translating data due to its simultaneous understanding of several modalities. Thus, photos can be converted to English, English to proteins, and then images to chemicals, and so on. It can now perform all of this translation as it comprehended all of the material at once. Vast amounts of text into little amounts of text, small amounts of text into vast amounts of text, and so on and so forth is what we refer to as generative AI. This computing revolution is currently underway. The great thing is that the first $1 trillion of data centers will be expedited and create generative AI, a new kind of software. This generative AI is a skill as well as a tool. Thus, the intriguing aspect is this. For this reason, a new industry has emerged. And the reason for that is that, if you look at the entire IT sector up to this point, we'd have been creating tools and instruments that people have never used before. We will develop abilities that enhance individuals. This is the reason why people believe AI will spread into the field of talents rather than just the trillion-dollar data centers. What exactly is a skill then? It takes expertise to be a digital chauffeur. Autonomous, a digital employee for planning, a digital customer service chatbot, a digital assembly line worker robot. Nvidia has digital employee service and uses ServiceNow extensively in its supply chain. Thus, we are currently experiencing a surge of artificial intelligence that essentially consists of all these digital humans. So take a step back and move about a bit. According to what you just said, there is undoubtedly a continuous discussion in the financial markets about whether or not there will be a sufficient return on investment as we develop this AI infrastructure. At this stage of the cycle, how would you rate the return on investment for customers? If you go back in time and consider, for example, the ROIs for PCs and cloud computing at comparable stages of their adoption cycles, how do they compare? The transistor and CPU scaling were concealed. Suddenly, we'd have already achieved cost and utilization reductions from each of these initiatives, and we are now done. And for that reason, we are currently witnessing inflation in data centers and computing. Therefore, accelerated computing is the first development that is taking place. As a result, it's normal for you to take on data processing tasks, and if any of you are aware, Spark is most likely the most popular data processing engine available today. A 20-to-1 speedup is common when using Spark and accelerating it with Nvidia and the cloud. As a result, you will save money, but you will also pay for the Nvidia GPU, which increases the CPU and slightly raises the cost of computing. It may double, but you save 10 times as much money by cutting down on computation time by around 20 times. Yes, and this type of return on investment for accelerated computing is not uncommon. Therefore, I would urge everyone to hasten anything they are able to. After you've accelerated it, use GPUs to run it. Thus, it is the immediate return on investment that acceleration provides. Beyond that, the discussion of generative AI is in the first wave of Gen AI, where cloud service providers and infrastructure players, like us, place the infrastructure in the cloud so that developers can use these machines to train, refine, guard, and so on using the models. The demand is so high that every $1 they spend with us results in $5 worth of rentals, so the return on that investment is amazing. And everything is sold out, and that's happening everywhere. As a result, the demand for this is just astounding. Naturally, we are already aware of some of the well-known programs, such as GitHub Copilot, ChatGPT, OpenAI, and code generators that we utilize in our business. The increases in productivity are just astounding. Not a single software engineer in our organization today does not utilize code generators, whether they are the ones we create for QDA, USD, Verilog, C, and C++, or the ones we use for QDA, another language we use in the organization. The idea that all of our software engineers would effectively have companion digital engineers working with them 24/7 is the future, in my opinion, and I believe that the days of software engineers writing every line of code are past. According to my perspective, Nvidia employs 32,000 people. But those 32,000 people are surrounded by, presumably, 100 times as many digital engineers. Yes, absolutely. It's really important to take a step back and realize that what we build is not a GPU chip. We call it Blackwell, and we call it DPU, but we're really building AI factories. These AI factories have CPUs and GPUs and really complicated memory. The systems are really complicated. It's connected by NVLink. There's an NVLink switch. There are InfiniBand switches, InfiniBand NICs, and now we have Ethernet switches and Ethernet NICs. All of this is connected together with this incredibly complicated spine called NVLink, and the amount of software that it takes to build and run all this is incredible. And so these AI factories are essentially what we build. We build it as a holistic unit, as a holistic architecture and platform. But then we disaggregate it so that our partners can take it and put it into data centers of any kind. And every single cloud has slightly different architectures and different stacks. And our stacks and our architecture can now be deeply integrated into theirs, but everybody's a little different. So we build it as an AI factory. We then disaggregate it so that everybody can have AI factories. This is just an incredible thing. And we do this at very high volume. It's just very, very hard to do. And so every component, every part of our data center is the most complex computer the world's ever made. And so it's sensible that almost everything is constrained. I would like to know how cloud providers compare to the other industries you claimed are entering the Gen AI space or purchasing Nvidia processors. You noted in the release's comments that we heard from CFO Colette Kress that 40% to 45% of data center revenue comes from those cloud providers. What does that mean for Nvidia as we see these other industries open up? Will the cloud providers, I suppose, lose some of their market share, and will these other industries take over where those cloud providers were? I expect both of them to grow. First, yes, Jeff, we like the financial setup. If you require any other changes, please let me know.